Hello students, in this video we'll consider the limit of a power function. So let's prove the limit as x approaches 3 of x squared is equal to 9. Okay, so we have a good sense of why this is true. If I plug in 3 over here, I'm going to get 9. But let's see the mechanics of the proof of this, recalling what the definition is. Remember that we need to show that for every epsilon greater than 0, there exists a delta greater than 0, such that 0 less than x minus, in this case, 3 less than delta implies that x squared minus 9 is less than epsilon. That's what we need to show. So remember, we do 2 phases of these limit problems. The first phase we do is we try to do some scrap work to see what we require of delta. So here's our scrap work. I'd like this to be true over here. I'd like x squared minus 9 absolute value to be less than epsilon. So I want x squared minus 9, here's our scrap work, less than epsilon. Of course, this factors into x minus 3 and then x plus 3. So I want x minus 3, x plus 3 to be less than epsilon. Now, I have good control over here because I know that that x minus 3 can be made less than delta over here. So this thing over here, I can estimate in terms of delta because I know that's in terms of delta. But then I don't know exactly how to estimate this term over here because it depends on what the range of x. So what we're going to do is we're going to test this against a certain value of delta. So if we choose a delta, let's choose delta, for example, choose delta to be 1. Well, if delta is 1, then x minus 3 in absolute value is less than 1, right? Which says what about the largest that x can be? Well, the largest that x can be in this case, we know that -1 is less than x minus 3 is less than 1. And if I add 3 to both sides, this can get a 2 less than x less than 4. So if delta is equal to 1, then the largest that x can be is 4, because the x is stuck between 2 and 4. So the absolute largest that x can be in this range of delta is x less than or equal to 4. Well, if that's the case, then this expression over here is no more than 7, because I have an absolute value of x plus an absolute value of 3 in this particular range of delta. So if I can choose delta to be epsilon over 7, and delta to be 1, then I'd be in good shape. But if I choose delta to be the smaller of those two things, I'll still get the same exact inequality. So here's what we're going to do. So I need 2 things. I need, if delta is equal to 1, I can conclude this range. And then if delta was equal to epsilon over 7, then we'd be in good shape over here too. So I would not choose delta to be the smaller of epsilon over 7 and 1. So let's proceed to our formal proof of this now. So here's our formal proof. Our formal proof goes as follows. Proof: let epsilon be greater than 0. That's how all these proofs start. And I'm going to choose delta to be the minimum of 1 and epsilon over 7. That tells me 2 things. That tells me that delta is less than 1, and it tells me that delta is less than or equal to 1, or delta is less than or equal to epsilon over 7. So I get 2 things for free from this. So this over here tells me that delta is less than or equal to 1, and delta is less than or equal to epsilon over 7. Those 2 inequalities from there. And so now, since delta is less than 1, well, let's do this first actually. So let's assume that we're in the right range. So suppose now that we're in this range, suppose 0 less than x minus 3 less than delta. Then since delta is less than or equal to 1, we can use this reasoning now to conclude that absolute value of x is less than or equal to 4, and therefore absolute value of x plus 3 by the triangle inequality is less than or equal to 4 plus 3, which is 7. So now we have an estimate on x and on x plus 3. So now let's consider x squared minus 9. X squared minus 9, as we know from our scrap work, is x minus 3 times x plus 3. We know that x plus 3 is no more than 7. And now I know that x minus 3 is less than delta by assumption over here. So that's less than 7 delta. And I know that delta is less than or equal to epsilon over 7. So this is less than or equal to 7 times epsilon over 7, which is equal to epsilon. So we've shown, what have we shown? We've shown that if 0 is less than x minus 3 is less than delta, that this implies that x squared minus 9 is less than epsilon, and this is exactly equivalent to saying that the limit as x approaches 3 of x squared is equal to 9, and that's the formal proof of this fact. Thank you very much.